Yeah, so going to be working on some spiral point cloud generator stuff today and some generic point cloud generator stuff today. Made some breakthroughs last night, but I'm just kind of getting started here. Let's see. Yeah. When I get set up. So I went and I did some research on modeling galaxies, and I incorporated some of the math into my spiral generator. I pretty much completely changed the way the spiral the this completely changed the spiral formula, but I think it looks better. It still needs like a central bulge, but I'm gonna make a change to the point cloud generators since the entire purpose of these generators is to fill octrees. What I realized is since the insert appears to be fine to do asynchronously, at least so far with my experiments, we're gonna change the point cloud function to take in the octree as one of the arguments to generate, or at least a pointer to it. And then we can derive extent from that, but we more importantly we can also do our inserts, which allows us to control our depths. Um, so all our randomization ends up taking place inside a single location, um, and that's kind of probably what I'm going to do first. And then after that's done, we're going to want to basically be looking into uh, making the point cloud generators that we'll need to populate a universe. But I can go ahead and show you kind of what I have. The brightness turned way up and I have the size turned way up. So it's like too bright, but I need it to be able to see it from a distance to make sure that the shape looks good. But this is kind of what we've got right now. You can see we have some number of arms um, going in different directions. And this is closer to what I was looking for. And also, we even have just the automatic lower density near the center, which is actually pretty useful because we'll do like a bulge, like a second point cloud calculation to make a bulge, or maybe not a second calculation, but like a concurrent one. And then also, it looks better from the side. It's not just collapsing down into like a flat line of stars. So I'm definitely going with this formula for galaxy generation, but there's like a lot of this is hard coded, so there's quite a bit of work to do here. Let's see. Um, so I think first what we want to do is revisit our interface for point cloud generation. So let's go here. So if we go up here, okay, we can, I think, delete these, but I'll leave it for the moment. So we shouldn't need this anymore. We pass the octree itself here. Shit, but this is gonna be circular. Because that's a Fogtree node, this class. And we're invoking the point cloud generator here. But I could move this invocation out to the actor level, which is like honestly it should be here anyway. Instead, init a point cloud generator as a tree fades out. Okay. Yeah, that should work. And that I like that. It's actually cleaner. We can just oops. Casey this and then um oh, it's in the header anyway, so it's perfect. And like there's a lot of cleanup to do in all these classes, but like right now we're just trying to land on a final design kind of. Okay. All right. This totally makes sense. And then what we're gonna do is go back over here to point cloud generator, change this in. So now we shouldn't need an extent anymore. So that'll be derivative of the octree. And then everything else can be configured internally, like on a per instance basis. Again, we can get rid of the extent here. We get rid of these input arrays. We no longer need the arrays to leave our domain, basically. T-shirt, octree. Okay. There we go. And then generate data. Okay, so okay, that looks good. And then we can go to our implementations here. These are gonna be wrong, but that's okay. We just need to clean these up. There we go. Generate data. We'll have to remake these arrays, so that's fine. All right. I do like this. And then we can just okay. Yeah. We'll start with these just named the same. Yeah. octree return. Octree is not valid, we return. Otherwise, we calculate the extent from the octree's extent. We have to pass it in. We need in octree extent in our arrays. Shit, we don't even need these arrays because they're not passing the data around anymore. Something like this. So that we have a reference to our seed value. Then we can just, because we already had, like, there's no need to construct additional arrays because we already have our data structure we want to hold this in. It's our octree. So I like this a lot better. It lets us cut out an entire second set of parallel fours to insert all this stuff. It does all the work in one pass. Position, depth data. We need to add some way to control typing. For instance, galaxy tree could contain stars, black holes, gas, all at different depths. Place with configurable depth randomization. Okay. That covers that change. Then we have spiral point cloud. I think we're going to get rid of the old one because this is definitely a better formula, in my opinion. all of these parameters will move because they're derivative of things like the extent. Get rid of these arrays. Keep the count here. And we're probably going to do things like move this count variable out of this function call as well into an internal parameter. And that way we can have like more granular control over it. Because I don't want to have to, like, ideally all our randomization for point cloud stuff can happen inside this generate data generation method. But for now, let's just do int 664 extent equals in tree extent. Okay, looks good. Okay, we do that, and then we come down here. We don't need these anymore, but we do need the tree. And the extent. And then finally down here, we can just do what we did. Insert position. Insert data. Auto. Insert depth. Let's make the order match too. Okay. Something like this. All right, great. So now okay, this is great. So now we remove a whole loop. Um, Generator equals new spiral point cloud generator. Um, seed. So this is no longer going to import this. Instead, we'll import it here. Do it. Raider data. These ordered. Okay. Ban this guy real quick. Go fuck yourself. Alright, so then we. Says it's good. Alright, so. Octree node. I like this a lot better because, like, the Octree node should not be responsible for its population. It's kind of just a data structure. So I like that. We can get rid of this. Try building. Maybe. Oh, it's not going to. Try doing this. Okay, so there's definitely something wrong with my configuration here. Yeah, so here's what I want to do. I want to do. Int count. Ah, this is why. Tree. Tree. Get rid of this. Get rid of this. Get rid of this. Back over to the implementation. Get rid of this. Get rid of this. And then, over here, generator dot count Beautiful. All right, so we do that, and then we get rid of this. This could actually all move into everything from here up. Move into the Niagara section. Yeah, I like this. And then we can simplify these lambdas. Go back out to actor. That was a void function. Or a no method signature. And then okay, do this. Down here. Seems fine. Ah, shit. It's actually not fine. We don't want that because you're doing the things off the main. Okay, I take it back. We don't want to calculate this stuff on the game thread. Calculate data into the tree. Extract data from tree. Extract arrays. As the arrays back to the game thread to instantiate system. Okay, there we go. This is, yeah, this is going to be wrong because now count. And I'm sure we have another one. Yep. See if it builds. It didn't, but I've been having this issue where it builds the second time. Yeah. All right, let's see if this works. The goal here being like a simpler interface between the point cloud generator and also like a better separation of concerns. Like the tree itself is just a data model. It's not responsible for populating its own data, for instance. Let's see if this worked. It did. Might have even been faster. I mean, it should be faster because um, there's a whole parallel for loop of inserts that doesn't have to run if I do it like this. Wish I could figure out what that blurring is. Motion blurring. But whatever. Alright. So there's our spiral. Let's try something. I just want to see if I switch this back to additive. right? And like as far as the character pawn, I needed a character pawn to effectively do the parallax calculations. So I just like get hacked in a flying movement into the third person character model for the moment. And obviously, the whole point of this is that it is parallax controlled with the static size. So, um, if we wanted it to behave like it was much larger, like right now it's a million units. Uh, if I wanted it to behave like it was 100 million units, I can set this and it slows everything down. This is the whole point of this operation, is to basically get this simple parallax mapping going on so that we can represent very large objects but also be able to like arbitrarily speed up or slow down going through them. Okay, so I think we need to do like a cleanup pass here now, and we want to do some stuff as far as like, okay, um, um, proceduralize parameters before entering population loop. All right, so we're gonna want to like, for example, proceduralize these parameters. All right, so another thing, we want to make sure that all of our stuff is still rigged up properly. So let's try 10 times less. That's pretty much instant. So if we want to do something that has 100,000 stars, we can generate that pretty much instantaneously, which is going to be important later. That looks great. It even has like different densities at different points of the arms. It's fucking great. Okay. Um, so I think at this point we would benefit from like a do our own code review pass. Just gonna commit these changes. Did changed signatures for point generators to take in the tree, so I don't skip an extra population loop as well as large arrays. And let's try to crank the scale now, because before we would hit big problems at like definitely at 10 million. Okay, this is 2 million. Just want to know how many stars we can generate into one of these galaxies and still like be reasonably performant. So let's try again. Let's try 10 million. Not 100 million. I'm pretty certain that would crash. 10 million. It is lagging. 10 million might be too many. Yeah. Max GPU per frame spawn. Okay. So we hit like a hard limit on Niagara. Um, we can binary search it out. 10 million is no go. What about 5? It looked like there was a 2 in there, so 2 million might actually be the max. Yeah. Okay. We could actually spawn more if we allowed it to stagger, but I think for our purposes, uh, let me guess. 2.5 million is also out of range. I think it's literally 2 million. Yep. I mean, I can see right there. So the maximum we can do in the system, 2 million. And that generates in, it looked like about a second. Almost want to turn off the post-process effect, at least for, I mean, I guess I could just go turn things off in it, right? We can keep our bloom, but just turn it off, and keep our lens flare settings, but turn it off. Yeah, that helps. Helps a bit. Go in the donut hole here. And again, the brightness here has been artificially inflated so that I can see the entire overall shape of the galaxy. We would cut that, we would dial that back whenever we are satisfied with our generation logic. Um, okay, okay. So I think next up, let's just commit whatever changes I got. That doesn't matter. So next up, we're gonna want to do like a little review and basically like a cleanup and polish pass here. Um, we may also want to create like some internal structs and bounds structs for these. 3 kpc for MW if extent is 20 kpc. Trying to figure out what this stuff was doing. Okay, degrees to radian, it's 6 here. Just want to kind of play with these values and see. What we may actually want to do is come up with some defaults for these. Um, and find a way to expose them so that we can just monkey with it without having to rebuild constantly. But for now, I kind of want to see what the various coefficients do. Alright, so I move that to a 3 and it tightens the spiral, is what it looks like that's doing. So then if I move to like 15, I'm gonna see what happens. Yeah, that's like spiral tightness for sure. Pretty cool. So like with something like this, you would drastically bump up um you drastically bump up the scattering coefficients. So like what if I did the same thing but with 10 times the horizontal spread? Now you still have the arms, but you have like enough spread to where they're not just hanging out on their own. Pretty cool. Daddy! Okay. All right, I'm back. So yeah, I'm gonna do like a personal code review here in a minute, and then we'll do some more point clouds. I still need globular. We're gonna need a noise influence cloud for laying out universal scale objects. Um, what else? What else do I need to do here? Let's see. Here. Percentage of the extent without exceeding. If we overflow the bounds, the points will get basically trying what scale be set for which parameters to ensure them. Here is the current. Extent minus horizontal spread. We want to kind of chase this out to the edges and make sure we're not overflowing the bounds. If not, we have a good calculation here for the extent calculation. looking pretty good here. I'm not seeing anything getting clamped. Okay, so that's good. All right, so let's start our review here. That's VS Code, no wonder. Um, so to start with, let's go to our octree node. This is very simple right now. I just basically re-implemented a very simple octree. We only have one insert method here. The other one is really nice and full-featured, but it wasn't exactly the way I wanted it, and it was like because it's full featured and it has like a whole suite of unit tests already in there. It was like very slow for me to change it. Like I just decided to rewrite the tree, and kind of only implement the things I need for this specifically, which is why this is a much smaller octree class, and this isn't fully done yet. Because like the next thing we're gonna need eventually is our like neighbor searching and things like that, so that we can tell what's close to us, so that we know when we need to populate a galaxy, or a star system. But we're not there yet. We're just kind of getting um, our various Lego pieces and building blocks constructed, so that we have all the tools we need to do that. So let's take a look at our simple implementation here. So we have an octree node. Index parent children looks good. 64 coordinate center is fine. Extent is fine. Data is fine. We have our null constructor and then our child constructor. Then we have f octree, the max depth and extent. Extents must be a power of 2 here. Um, we have our root node, which is shared pointer. Um, we have our implementation of insert position. This basically gives us a position, a depth, and a data, and we will insert that data object in that node, in the node at the depth and position that corresponds. Seems fine. And then we have a helper method here. If you don't want to determine depth, this will just insert at max depth. Okay, fine. Collect leaf nodes. It's fine. Just populates an array of leaf nodes. Give it excuse me. Give it a node. Populates the leaf nodes. And then get leaf nodes just invokes collect on the root. Looks fine. And we have our constructor. It takes an extent, a max depth, and a root. And what I've realized is that like the octree should probably not care about like the world scale. Like just do our operations on the octree in its own natively in its own N64 coordinate scale, and then in the wrapping object, the actor that's going to utilize this as a backing data model for something, then there we can actually like um, do our like world scale conversions and things like that. Because this is not an actor; it's just a data. It's just a header file for a bunch of simple classes. Okay, and so the only two things in here are our node and our octree, which I think is fine. I should have probably called it. I should have probably renamed the file um, to Fogtree instead of Fogtree nodes, since it contains both, but whatever. Data types, just a header file with our voxel data struct and our int64 coordinate struct. Uh, okay, so far so good. Sparse voxel actor. This is our wrapping object. I should have probably called this a parallax voxel actor. So that's really what it's doing, is managing parallax and some other stuff. But for now, we'll just leave it named the same. We can always come back and fix all our names up at the very end. Um, so this is going to get an extent, a unit scale, speed scale, a seed, and a count. Count is the only thing I'm not sure about here, but we'll leave it for the moment because it's convenient. And change the order of these. This also manages spawning in um, the actual Niagara system to correspond with this. Okay, looks good, looks good. Everything here seems fine. Now we have an init call. Set this actor called tick every frame. Yes. Our path. Yes. Default scene route. Yes. Okay. All that looks fine. Init. Okay, so here's how our initialize work. We hop on an alternate thread. We initialize our awk tree. We initialize our generator. We initialize the count on our generator. Okay, so let's make a comment here. Do any pre-configuration of the point cloud generator here. Setting randomization bounds etc. We're gonna come back to this. Okay, it's good. We might add another function here. I think this is fine. Okay, seems fine. Seems fine. And then we spawn our Niagara component, and then we have our debug draw tree, which is gonna probably get phased out pretty soon, but we may need it eventually. I don't think it would work right now because, like, right now we're rendering it in world space, but it has no parallax. So that is what it is. Um, okay, so this is like how we can do parallax if we don't have a pawn, but we do, so I think it's fine. And then here's our parallax calculations. this. I think this has to go in the constructor. Something like this. Initialize our subsystems in the constructor here. It's not uninitialized though, yeah. It's not true. Okay, we can always roll it back, but go ahead and rebuild. Okay. Okay. What's this? Not now. What's this? What? Okay. Doesn't like that. Starting to look pretty good, at least the spiral part. Like, remember, we still have to generate another piece of this puzzle. We have to jam um, like a bulge in the middle, which will cover kind of the hole there, as well as just like some ambient stars around the rest of it. But I do think that we can go ahead and increase the Where'd it go? Point cloud generator. Point cloud generator. Do you think we can increase the vertical spread here? Should maybe like a point two. So far, so good. I don't see a problem with the point two. It's actually might be a problem with the uh, vertical spread power here. All of this stuff has to be parameterized. Softer spirals, softer vertical distribution as well. Cool. Let's keep these at 2 for now. And actually, let's go ahead and parameterize them up here. So we'll do Jones spread fall plus 2. Vertical spread fall off equals 2. Move these down here. Yeah, okay, so we need to go back out to here. Spread, fall off, vertical, spread, fall off. But mainly today, now that I have a spiral function that I'm pretty satisfied with, it's just about like finding good default values for all this. Um, Getting everything that should be parameterized. Vertical. Depth range. So, looking for any constants that are being used, right? That are not constants that are being used that shouldn't be. So, for example, this value here should probably be a value. I believe this makes a bigger donut hole. Bigger donut hole. Yep. Okay. So scale length 0.01. Center scale. Go back out to the header. Center scale length. Okay. Back over to the generator. Looks good. Um, Max insertion depth. Min insertion depth equals in tree max depth minus for now. And then we can go back out to do math, fmath, max this and 0. We don't want to try to insert a deeper depth than 1 actually. Don't want to insert in the root node. And then we can go out to here and we'll do this could almost be like these are all spiral specific, right? But the scale is not. It's insertion depth max insertion depth. And then back over here. It's that dyslexia getting me right there. We can do them like this, and then down here, rand range, min, insertion depth, max, insertion depth. Um, Something like this. And then likewise over here in simple distribution. Insertion depth equal. And we're also trying to move anything insertion depth out of the functional part of this into the, we want to kind of segment this into conceptual parts. Like this part's the generation block. We don't want any constants declared in here. And this part is the like configure your bounds part. So like anything that's affecting the output, we would like to be defined up here. And then we can do this. Min insertion depth max insertion depth. Let's move this. Oh, and we're passing extent and octree, which we don't need to do. Extent is a property of the octree, so we can just delete this. Extent equals. I guess it's fine. Stops us from having to query it on every iteration of the loop. Never mind, I don't like it. We'll get rid of it. This is really the only place we use extent. I'm impressed by that. Now we can delete this. And we can delete it up here too. Looks good. So the only thing we pass in is ourself and the octree. That's great. Very simple. Alright, and for now, we're going to get rid of these bounds. That's coming. But for now, let's just set some static values and get them looking good. These should probably be... Well, I don't know. We'll figure it out. Because like the trick here is you want these values to be like the adjustable piece of it. So I don't necessarily like having multiplied by extent at this level. Like I'd rather this just be zero point 0.2, zero point 0.5, and then like the extent happens later. Okay. Let's test those changes. Spawn. We have our spiral. Just thinking here. Let's get like with like. So these are arm changes. Then we have scales, or maybe spread calculations, then scale calculations. Height bounds. Distance from center. Spiral begins. Under scale length. But they should actually be multiplied by the scale length. And then we can just use it directly. Okay. And then we want to figure out how to split off all of these. Scale. Basically trying to get all of these down to just pure coefficients. Let's go back over here and add one more.
Read that. Something like this.
All right, so now we have everything split up. These are all derivative. These are all derivative, no constants except for this, which needs to change. Let's call this center. I'm just thinking this should probably. If I changed all these things named scale here to be named distance. Oops. Center distance, center scale. So all that's good. Then max insertion depth, max depth, min insertion depth, calculated from the max depth. Horizontal spread distance equals the extent times the horizontal spread. Vertical spread distance equals the extent times the vertical distance. This should be times the vertical spread. Because it's not set yet. Ah, it's not used. What? Vertical spread, horizontal spread. Ah, I see. And then this is the same value. This is not used anywhere else. Now we can go back out here. We don't need this. Um, this comes up here. Scale distances. So far, so good. Let's so like if we were exposing this stuff, these would be like public. And the distances down there would be private because they're derived. Minimax insertion depths are derived as well. Oh, they're up here. Okay. So let's make sure that everything still works with those changes. Oh, I goofed. I blew it. Something's probably using one of these values where it shouldn't be. Right here's one. Try again. There we go. I'm gonna follow this arm and make sure that we're not overflowing boundaries anywhere along it. Oh, these are overflowing boundaries. There it is. Okay, yeah, that's why. Because this is supposed to be just spread this, I think. And go ahead and take a jaunt around the outer arms here and look for anything overflowing the boundaries. Oh, I found it. Okay, so what we're gonna do, save everything. Let's roll back, way back. I want to see what it had before I changed this from disk scale. So, looks like this would have always been a problem. Let's revert this. Um, all right.
Floating through the velvet night, sin gravidad no hay final.
Okay, so these
Secrets shine bright,
the machine. Alright, so min radius, max radius. This, add another. Okay. Make radio 12.5. Try that.
Floating through the velvet night, seeing grave that wifey Nile. Stars whisper secrets, shining bright, lejos de todo, cerca del mar. Dérive doucement en el cosmos, todo es tan calmado. Drift, flotando en paz, la eternidad nos ha encontrado. Echoes hum in the galaxy's vein.
Is it just a circle? Alright, hang on. We can actually improve the visibility here.
Like sugar in rain dans l'infini, tout devient rien. Shadows of planets pirouette slow. Les lunes dansent un ballet flou. Espacio eterno where dreams overflow. Lost and found dans ces flambeaux. Dérive doucement en el cosmos, todo está calmado.
Okay, looking at what's spiral.
Flotando en paz, la eternidad
Is
nos
a circular ring around the entire side. We need to switch. Alright, seems to be flowing the Let's see what this fallout function does if I do this. Let's try something large. I'm not sure if I should be going up or down with this. Let's try going down with it. Okay. That bites everything to the outside. 32. Hang on. Idea. Seems the radius to it. It's a bit section generate. Let's give this a shot. Oops. Nope. Nope. For that. Hey. Yeah, now when I look at that again.
Grasping at dreams, oh so tight.
Closer.
Echoed as it swelled. It calls, it pulls, it scars through the void. I float afar. Black holes hum their haunting song. The planet dawns and some fit. I wonder where I belong. Is it here or a life I left behind? Ich fliege, ich falle in diesem leeren Rahmen, timeless waltz.
Let's see.
Lost in whispers, the universe, my
Beautiful. Ah, this is why. Yep. That's it. Pretty sure. Pretty sure that's the issue right there. As far as these overlaps, yeah, okay, that fixes that part. And what is this? Let's try increasing the inner radius. What am I?
Stars whisper secrets
The
they
fuck?
can't keep. Unmarred, elusive, infinite. The void feels heavy, yet so small. Zero gravity holds
center, scale, starting from city. Radius equals center distance times Alright, it does work. Okay, it's getting closer. The spiral part is good. Near grid like distributions occurring as well. Perhaps
Je danse dans l'éternité de la nuit. I'm a drifter, a shadow, a spark. 飘摇流在宇宙光明与黑暗。No up, no down, just endless arc, lost in space.
center.
A comet's tail sweeps by my side. My heartbeat echoes, time's denied. Dans l'obscurité, je trouve la paix. A galaxy sings far away. Infinity whispers, you are free. Estás perdido, pero aquí. Planets turn, I hear them hymn. 飘飘着，在无尽
think we just poke at it for a bit. No. Maybe we ask a different coworker.
Afloat in the silence, a ship without chains.
Point cloud.
Stars blink like secrets
Good
they'll
mouth, but
never explain.
just spiral. There are like distributions occurring that to see rid of. These generation code. It looks like it's occurring at the start of each arm. Let's see what it thinks. Okay. So it thinks their usage of pitch angle as a 10. Right here. Copy this.
Afloat in the silence, a ship without chains. El vacío me llama, susurra mi name. Stars blink
Oops.
Planets like whispers, they circle, they spin. Sora no koe ga watashi o yobikomu. Sin peso, sin tiempo, el cosmos mezquin. Gravity fades. Where does it begin? Where's the start? Where's the end? Doko ni iru ka mo wakaranai. Lost but I'm free, no need to pretend. Drifting, drifting, no ground below. Tadayotte, tadayotte, yuku soeto. Flotando en polvo de estrellas sin fin. In the void I begin. I touch the edges of infinite dreams, rozando bordes de luz y de sombras. Hirogaru hateshinai magare, the endless expanse tears up my seams.
Let's see. Is it a 10? I know. Is it doing that?
Floating past the silver glow.
Yeah, let's see.
No map, no line, just a silent flow. El universo sin rumbo va. A drifting stardust, lost but free. Floating past the silver glow, Hoshikuzuga odoru yoru. No map, no line, just a silent flow. El universo sin rumbo va, adrift in stardust, lost but free. Tadayo hoshi no naka de, the cosmos sings, it's calling me. Cantando al
Am I doing a second?
mirrors of ice in endless black. Hatenai ami no naka.
Yeah, that was definitely an issue.
Echoes of stars, no turning back. Un viaje eterno sin hogar. Which way is up? Which way is down?
I mean, that's a pretty perfect spiral, so it has to be the jitter function, is what it seems like. So let's go back and add jitter back in. I can also confirm the issue is related to the jitter, not the spiral function, as the spiral function is generated from Hey, Jinx.
Floating here in the quiet glow, stars whisper secrets I'll never know. Dans la vie, je perds mes mots.
legs are releasing skills.
Auroras twist, they take my hand. I dance through galaxies so grand. Adrift in cosmic streams. El universo guarda mis dreams. No arriba, no abajo, just in between. Adrift in mi corazón pero suave, Satan is symphony, se vertigo. I see no edge, no start, no end. Space is my lover, my only friend.
Alright, now we're getting somewhere. So that's what it was. Because we were jittering in Squarespace, basically. Like, we were just jittering by, like, a cubic amount. But now we're doing it in terms of a... Oh, yeah, baby. That's the way. But now we're doing it in a radial jitter. Alright. Nice. So now, what if we change this to like a 4 and make it more tightly conform to the vertical axis than the horizontal? This is definitely closer to what we're looking for. Yeah, that's looking pretty good. Yep, and it's not using the fall off anymore properly. Yes. Okay. Um, Max spread. Um, this is extremely close now. The only issue is we properly using values. Um, we need to be ultimately control sequences. I think we can actually. Vertical.
So alright, so that I think does it. Alright, let's see if this works. Alright, so check the radio fall off. Okay. It does work. Concentrating them at the ends. So invert it. Yeah. Invert. Hey, look at this. This is close. There's your spiral galaxy. It's
looking pretty good. I think our formula is about complete here. Alright, so turning this up increases like the angle, makes the spiral less tight basically. So
I float through the void, no dead and no sound.
good.
Les étoiles dans ce que je
List.
suis perdu trouvé.
Spread.
Every star a whisper, every light a dream. 跳到幽流中，我们的影子消失在夜空的边缘。Time slows, it bends, it fades away. El tiempo se desvanece en el infinito.
Even the shape has got like better, like it's got like a lumpier profile instead of just a flat line. It's actually looking pretty good. So next up, mess around with these actors.
Nebula clouds paint skies of fire. Los colores giran una eterna espiral. No up, no down, no
Gonna get
place,
a profile shot.
Les galaxies s'étreignent dans un doux tourbillon. What's left of me?
This might be a little too high. This might be a little too low. This is probably too high. I mean, that to me looks pretty much like a galaxy. I think we may have the base formula done. Let's try something else. I go over here, and I go here, and I go here, and I switch this from translucent to additive.
Save that bitch. Close it.
I flow through the void, no tether, no sound. Les étoiles dansent autour, je suis perdu et trouvé.
Alright, so now if we want to increase visibility, we could go here and reduce our extent. That'll cause everything to be bigger. Right, and let's try reducing this value to much smaller. What happens when we do that? Divide by 0 probably. So do like 0.01. My assumption is that we had to divide by 0 there, probably. Alright, that's too much. Let's do 0.5. Alright, so let's try a couple of things. Reduce the radial fall off, or reduce the vertical fall off, or increase the horizontal fall off. Just want to pick out more distinct limbs.
drop this again, drop this again, and maybe drop this in half. And maybe bump this up.
Floating through the velvet black. Last Estrella, she called my name. No turning back. A whisper of light. A cosmic track.
Alright, I think that's pretty good. I'm gonna go get some lunch and shit. So, and take my dog out for walkies and all that nonsense. But I think it's doing a pretty good job of making a spiral point cloud now that can stand in for a galaxy. And it's quick too. So 1, 2, 3, 1, 2, 3. So this is 2 million points. And takes about half a second. And they're like persistent, so we could like index into any of these stars and generate additional data. Of course, it's got our parallax harness. So we can change the speed at which it moves arbitrarily, and thus the scale, the perceived scale. Obviously, we still need to do some material work. I just did the bare bones basics needed to get like a little glowing star sprite, but we're gonna wanna do some additional work there. Alright, I will be back later. See ya.